Hello there, you beautiful people. We now know a lot of stuff in Python. As well as knowing about variables and if statements for creating logic, you also know how to use strings, integers, floats, and Boolean data types, which is awesome. These are the building blocks of a lot of Python programs, and you should be super proud of yourself for making it this far. You've really learned a lot, and I'm very proud of you. So, sometimes, believe it or not, it's actually inconvenient and inefficient to have these little pieces of data floating around, each with their own variable name. Python data structures make it possible to group massive amounts of data together and store them all under one variable name. Now, data structures make it possible to operate on thousands or even millions of pieces of data all at once in a single line of code. Crazy, right? So Python gives us a variety of data structures that we can use, including lists, tuples, and dictionaries. And in this section, we're going to teach you all about all three of them. We're going to cover what they are, how to make them, and some cool stuff that you can do with them. You're going to be building two projects in this section, which is quite cool, right? So first of all, you're going to build Travis, the ridiculous security system. Travis will have a list of known users in his security database, and he will be able to detect an intruder. However, Travis is ever so polite, so whenever he finds an intruder, he's just going to ask them if they want to be added to the list. This project will teach you all about combining logic with your Python data structures, which is an incredibly powerful ability, so you'll want to watch out for that. You're also going to be building a cinema booking simulator. The cinema is going to have a list of films with their appropriate age ratings and the amount of seats left. When a user comes to buy a ticket, the computer will ask for their age and check if there are enough tickets left before allowing the user to buy a ticket. Nice, right? So by the end of this section of the course, you're going to know about Python's data structures, how to make them, how to use them, and in what circumstances each type of data structure works best. So in the next lecture, we're going to jump in and discover the first and most common type of Python data structure, which are lists. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture about the most common of all Python data structures, lists. So in this lecture, you're going to learn what lists are, how to create them, and some things that you can use them for. We're also going to see how to add things to a list, how to get data from a list, and also how to slice a list into little useful pieces. So in the process, you're also going to learn how to create tables and matrices in Python, and you will also be introduced to Python's very useful in keyword, and you're also going to learn how to combine lists with logic. So let's get cracking. Okay, so first things first, how do we create a list? Well, we create a list by using square angle brackets. So let's say we had a variable called our list, and we set that equal to a list with 5 numbers in it. We would type our list equals, then open a pair of square brackets, and in here I'm just going to put 5 numbers with commas in between them. So let's say we've got 27, 46, minus 5, 17, and 99. Okay, now when I press enter, that's gone and saved itself in there. Now when I print our list, we're going to see that we had 5 numbers printed to the screen rather than just 1, which, before when we use normal variables, you could only just get 1 value out. So that's pretty nice and easy, right? And if we use the type function, just to show it to you, type of our list, it's going to tell us that it's a list. Nice and straightforward. Now, a really cool thing about Python lists, unlike those in other languages, is that Python lists can have multiple data types inside them. For example, you can have a list that contains numbers, strings, and booleans. So for example, if I create a list called Jackson, and I set that equal to, inside here, A, B, C, 1, 2, 3, do, oops, I need a comma, do, re, mi, true, and false. Okay, so if I do that, that's all going to work fine, and that's totally valid code, and most of it is also a musical classic, which is a nice bonus. Now, lists in Python are an iterable data type, just like strings are. Now, if you remember from our previous discussion on strings, and if a data type is iterable, that means it can be broken up into little pieces called elements. And each element has its own index, which start at 0 and they count up from there to allow you to access the element. So for example, the letter A inside Jackson here would have index 0, this would be index 1, this would be index 2, and so on. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so how can I access a specific element? Well, the way that I can do it, let's say I wanted to just get the number 2 from here, right? That's 1, 2, 3, 4, oh, sorry, 0, 1, 2, 3, 4, index 4. So the way that I'd type it is I'd say Jackson, open up some square brackets, and type the index in there. Now when I press enter, we're going to get back 2, because number 2 is at index 4. What if I wanted to get Ray? Well, this is index 4, index 5, index 6, index 7 should be Ray, the string. So Jackson of 7, and we're going to get that out. And you don't have to count all the way from the start like we discussed before. You can count back from the end. So let's say if I wanted this, the element at the very end has index -1, and this one would have -2, -3, -4, -5, and so on. So let's say if we wanted true, what we'd have to type is Jackson of -2. And if I press enter, that's going to give us true. So that's how you can get certain elements from a list. Now you can save these elements in variables as well. So let's say if I wanted to get just dough, I could say x equals Jackson of 0, 1, 2, 3, 4, 5, 6, 7. And, oh no, not 7, 6. And what that's going to do is it's going to hopefully save in there dough. So you can see you can take little pieces out like that. So what if you wanted to take out more than one element? Well, for this you need a slice. We've discussed slices previously in the section on strings, so go back and have a look at those lectures for more information, but I'm just going to give you the basics of how it works. So let's say we wanted to take out from Jackson A, B, C, right, into its own little list. Well, the way that we do that is we would basically say Jackson, open up some square brackets, just like we were doing for one element, and you tell it where you want to start, then a colon, where you want to go up to, but not include, so I'm going to call that end, you don't include that one, and then the step, okay? The amount of steps you want to take in between each item, which defaults to 1. So let's say we want A, B, C. We want to go from index 0, because that's A. We want to go up to the 1, but not including it, which is going to be index 0, 1, 2, 3. Okay, and if we don't do anything, that Python's just going to assume the step is 1. So let's just do that. And you're going to see we get A, B, C as its own slice of the list. Now, if we look at Jackson, the original data, you're going to see that that hasn't been changed. And the reason for that is slices just take a copy of the original information. They don't replace it at all. If I did want to replace it, I would have to overwrite the list in some way. Now, this is where lists get interesting. Lists can have other lists inside of themselves. That's right. We're working with listception. Okay. So, for example, let's say we had a list called. Let's just overwrite our list and set it equal to 1, 2. Then we put another list inside, which was 3, 4, 5. Then we had 6, 7, and 8. Okay, so you can see we've got a big list here, and then inside of it we've got another list. So let's save that. That works fine. So how can we get this big list from in here? Well, it works pretty much in exactly the same way. So this is index 0. This is index 1. This whole list is index 2. So if I show you that, our list, index 2, we get a whole list out. But what if I wanted to get the number 3? Just the number 3. Well, the way that I do that is what I would do. Okay, so you agree that this gives us this list. Okay, what index in this little list is the number 3? It's index 0, right? Because this is index 0, index 1, index 2 of the small list. So we just put another little bracket here, and we say we want index 0, and that's going to give us out 3. So we want index 0 of the second index of the big list. The second index of the big list is 345, and index 0 of 345 is 3. Likewise, if I had index 1 of that, we're going to get 4. And if I wanted index 2 of that, we're going to get 5. Okay? And these follow all the same slicing rules. So I could say I want from index 1 to the end. We're going to get 4 and 5. Or I could say I want from index 0 to the end in steps of 2. And we're going to get 3 and 5. So you can mix and match in any way that you'd like, which makes lists really, really powerful. So why the hell would you ever use this, I hear you ask? Well, this comes up quite a lot when you try to create tables in Python. So imagine if we had a list like this. We're gonna call it our table equals. We're gonna have a big list. Then inside there, we're gonna have 1, 2, 3 in its own list. We're gonna have 4, 5, 6 in its own list, and we're gonna have 7, 8, 9 in its own list. So let me just put some spaces in here so it's a bit easier to see what's going on. So we've got a list with 3 lists inside of it. Okay. Now, what happens if we type in our table of 0? What do you think that's going to give? If you guess it's going to give 1, 2, 3, you'd be right. And likewise, we can do our table 1 and our table of 2 to get the other lists inside there. So to select any one number, we need 2 coordinates, effectively, don't we? Say if I wanted the number 2, I'd have to type our table 0 and 1, right? To get the number 2. So what this means is the first coordinate, if you can imagine with me, the first coordinate is basically acting like the row, because if you imagine like a telephone directory, like, the keys on your telephone, the first coordinate gets us the first row, or the row of it. So row 0 is 1, 2, 3, row 1 is 4, 5, 6, and row 2 is 7, 8, 9. And the second coordinate basically gives you the column. So if I have, this is column 0, column 1, column 2. Let's say if I wanted 6, right? That's going to be on row 1, column 2. So what I do is our table, row 1, column 2, and we get out 6. So what do you think, let's say 8. What do you think you'd have to do to get 8? If you guessed you have our table, row 2, because it starts at 0, 0, 1, 2, and then column 2, or column 1, 0, 1, you're going to get 8, okay? So you can see we've basically made a table with rows and columns. Now you can have lists inside of these other lists to make 3-dimensional cubes and so on, and go on for as long as you like. You probably won't ever need to, but it's possible. And hey, it might come in useful if you ever want to create a Rubik's Cube solving robot, or something that you want to keep a track of where all the colors are on the cube, for example. Now we can take slices of these smaller lists if we wanted to. So let's say I just wanted 5 and 6. Yeah, I go our table, it's going to be row 1, and I want from index 1 to the end, and we're going to get 5 and 6, and so on and so on. And it basically gives you a lot of control about what data you want, but it's more useful to think of these things just as tables. First you set the row, then you set the column, and you can use slices and things like that to pick specific data that you want. Okay, so I'll give you a break there, as we've covered quite a bit in this lecture, right? So let's just take a step back and digest it all before moving on to the next lecture. We first took a look at how to create lists. You saw how simple lists are to create, as all you needed was a set of square angle brackets, and just put the data inside with commas in between it. And after that, you learned that Python lists can hold multiple different data types at once, which makes them incredibly powerful, and we made a list that held strings, numbers, booleans, and lyrical genius all at the same time. You then learn how to access certain elements from a list by using the element index. Because lists are iterable data types, just like strings, accessing elements was the same as we've seen before when working with strings and slices. And yes, you can slice lists as well, and that works exactly the same. So finally, you learned how to create multi-dimensional data structures, like tables, by putting lists inside of lists, and then using several coordinates like rows and columns to access the elements. Now, while you won't be using these every day, it might come in handy, and you've got this lecture for reference, when you're building that Rubik's Cube solving robot that you've been dreaming about. So one thing to bear in mind is that slices don't actually modify the list in any way. That's just something to bear in mind. It just takes a copy of the data that you slice out. Now, up next, we're going to move on to our next project, which is going to be creating Travis, the ridiculous security system. By building Travis, you're going to learn how to combine lists with logic that we learned in the last section, and this is going to level up your Python skills so much that it's crazy. So I can't wait to show you, and I'll see you in the next video. Okay, so how useful are lists if you can't add and remove data from them automatically? The answer is not very. So in this lecture, we're going to go over how to add and remove data from lists, and you're also going to learn how to use the in keyword to check whether something is in your data or not. To illustrate these points, we're going to create a rather ridiculous security program. This program, called Travis, is going to have a list of known users, and every time it runs, it's going to ask for your name. If you are in the list of known users, it will welcome you and ask if you want to be removed from the list. If it doesn't recognize you, it will ask if you would like to be added to the list. Now, this is the most ridiculous security program ever, but it will let us illustrate how to do some pretty cool things with Python lists. So by the end of this lecture, you're going to know how to add and remove items from your Python lists, as well as check whether certain pieces of data are in your lists or not. You're also going to know how to combine all of this with logical if statements to control your code. And on top of all of that, you're going to have built an utterly useless program and hopefully had a few laughs. What's not to love? So let's get cracking. Alright, so the first thing we're going to want to do is create a new script. I'm going to call mine travis.py because Travis is the name of our security robot. So let me just go to the desktop here, Python Bible, travis.py, and click enter. Maximize the screen, and fabulous, we are good to go. Right, so the first thing we're going to want is a list of known users. So let's create that first. Known users equals Alice, Bob, Claire, Dan, Emma, Fred, Georgie, and Harry. Okay, so there's our list of known users. Now there's quite a few of them, right? If we wanted to know how many there were, we could just print the length using len of known users. Now when I save and run that, we're going to see it tells us 8, because there are indeed 8 users in this list. 1, 2, 3, 4, 5, 6, 7, 8. The length function basically tells you the amount of elements in your iterable. So that's a handy trick to what you're going to want to keep hold of. Okay, now I'm going to cheat a little bit to make Travis a lot more functional by using something that I haven't actually introduced you to all that much yet. So I'm going to type here while true and type a colon, then go on to the next line. Now this is going to create what's called a while loop. Now don't worry about this for now, as we're going to cover loops properly in the next section of the course. But in summary, this line here is going to basically make whatever we type inside of the while loop run over and over and over and over forever. Okay, next I'm going to make Travis introduce himself. So I'm just going to type in here print, hi, my name is Travis. Okay, now we want to ask the user's name and store that somewhere. So as a quick micro challenge, try and use what you've learned about user input to ask the question, what is your name? And store the answer in a variable called name. Pause the video now and have a go, then come back here to see how you did. So how'd you get on? Well, I'd have done it like this. I'd have just typed name equals input, using the input function, what is your name, like that, and just for extra security I'm going to put the strip function at the end in case the user accidentally enters a space. So if you got that, well done. You're definitely learning something from the course, right? And you've internalized all this information. So now we're going to want to check whether that name is in the list of known users or not. So for that, we're going to need some logic. So let me introduce you to the in Python keyword. I'm just going to jump over to the regular old Python shell, and I'm going to make a list called L, and I'm going to put in that 152, L equals 15269. Okay, now using the in keyword, we can tell whether something is in something else. So if I type 2 in L, we're going to get true, because the number 2 is in L. Now, how cool is that, right? That's quite nice. If I did 10 in L, it's going to give us false because 10 isn't in L. So we can use these in conditions in our program. By the way, this is like a superpower when you compare it to how you'd have to do this in other programming languages. So just trust me on that. It's ridiculous in other languages. So we're going to need an if statement. Let's go back in here. We've got their name, right? And we want to check if that name is in our list of known users. All we have to do, if name in known users. Okay, then we do something. We would print, let's say, name recognized. Yeah, and if it's not, we just need to type else print name not recognized. So let's save and run and test that. Okay, so let's say I come in, it says, what is your name? I type in Alice, because Alice is in the list, and it says name recognized. Then the loop makes the program start again. So what is your name? And let's say I put in Z, and it says name not recognized. So now we've got a way, just using the simple in keyword, that the program can ask us for a name, and it can check whether that name is in the list or not, which is brilliant. So one thing that I want to show you is Alice with a capital A work correctly, right? Now, you know that strings are case sensitive. So watch what happens if I just type in Alice in lowercase. It's going to say the name isn't recognized because Alice in all lowercase isn't in the list, but Alice with a capital A is. So we need to fix that somehow and allow our user to pretty much enter their name however they like. So we're going to do that next. But by the way, if you want to stop a loop running, you hold Control and C, and that's going to cancel the loop. I mean, this isn't a problem. It just says keyboard interrupt. I just stopped the loop working. So let's head back on over to our script. And now I want to see whether you can remember, how do you make the first letter of a string capitalized? Now, you may have guessed that we use the capitalize method, right? So what I'm going to do, if you did, by the way, that's fantastic. What we're going to do is when the user inputs their name, we're first of all going to strip off any white space, and then we're going to capitalize it. So you can see here that we've got one function, we've used a method on it, then we've used another method on that, and you can just stick on, like, methods after methods after methods, as long as they're all the same data type, by just using the dot method, and stuff like that. It doesn't matter how many you have. So now we're stripping off the white space and capitalizing it. So if I save and run it, we're going to see that if I type in Alice with a capital A, that works. It says name recognized. But if I type Alice with a lowercase a, it's also going to say name recognized, because internally it is saving the name as capital A, and then it's checking that. So we've given our user some more flexibility, which is nice and cool. So as this video is getting a bit long, I'm going to cut it here, and we're going to continue building Travis in the next video. So I'll see you there. Hello there, you beautiful people, and welcome back to this video where we're going to continue building Travis, the ridiculous security system. So at the minute, we have a computer program that can ask a user for their name, strip off any white space, capitalize the name, and then check if that is in a list of known users. But at the minute, we kind of print out these very formal name recognized or name not recognized messages, right? And Travis isn't like that. Travis is very polite. So we want Travis to be able to say, hello, so-and-so, if their name is recognized. And for that, we're going to use string formatting. So as a micro challenge to you, I want you to go ahead and write some code that's going to print out the message, hello Alice, or hello Bob, or hello Emma, or whatever their name that they enter might be, as in this if statement here. So only if they are a known user. So pause the video now and print out to the screen a string that says hello, whatever their name is, using string formatting, and come back to see how you did. So how'd you get on? Was it all right? Well, this is the way that I'd have gone about it. I'd have deleted this ugly message here and typed print. Then inside here, I type hello, space, some blank, exclamation mark, then format inside that blank space their name. So the user's name is going to go in this blank space. So if they entered Alice, it would say, hello, Alice. Or if it was Claire, hello, Claire, or whatever it may be. So if you got that, or you managed to get the same functionality, then well done. You're honestly learning so much from this course, and I'm really proud of you now that you're applying these really complicated concepts. It's amazing. So now that we've replaced our ugly name recognize with a nice welcoming message, we want to ask the user whether they'd like to be removed from the database. Because at the end of the day, Travis is pretty ridiculous. So let's create a variable called remove and ask them, using the input function, would you like to be removed from the system? Okay, and I'm actually going to put in y/n there so they can see that they've got to enter yes/no. Okay, so what that's going to do is the user is going to type in yes or no, right? Now, if we want to check whether they entered yes or a y, one way we could do it is this. We could have another if statement in here, and we could type if remove equals y, or remove equals capital Y, right? Because if they enter a lowercase y, this will be true. Or if they enter an uppercase y, this will be true. Then the whole condition will be true because we used an or statement, and then the code, whatever we put in here, is going to run. But that's kind of a bit ugly, right? Like before, I'm actually going to use the lower string method on here. So no matter what they enter, if they enter an uppercase y or a lowercase y, we're going to convert it to lowercase and save that in remove. So now all I have to do is just check if remove is lowercase, because we've already converted it to lowercase up here. We just have to check whether it's the lowercase y. So now inside of here, I'm going to want to remove the name from the list. Now there's a neat way to do this using the remove list method. Now list methods work exactly the same way as string methods, it's just they are for lists. So all we've got to do, if they want to be removed, we do known users.remove name. It's as simple as that. That's how you remove someone from a list. So this is an excellent example of how Python makes something that could be incredibly complicated so simple and easy to read. This is going to remove the first occurrence of the name from the list. So bear in mind that we're going to remove the name. So say if there was Alice and Alice and Alice, if we just did remove Alice, it would only remove one of them. It would remove the first one that it found. So that's something you need to bear in mind. So this code is only going to work for us as long as the name occurs once. If it occurs more than once, you might need to use a loop to repeat the remove process as many times as necessary, but we'll save that discussion for another day. So let's just check this is working by printing out the list before and after the removal. So in here, I'm going to print the list. And down here, I'm going to print the list as well. Let me just get rid. Is there anything else I need to remove? Yeah, I just want to get rid of this bit up here where we print the length of the list. We don't need that. So let me just run this. It's going to say, hi, my name is Travis. What is your name? I'm going to say Alice. Hello, Alice. So our string formatting worked. Would you like to be removed from the system? Let's click yes. Okay. So at the beginning, we've got Alice, Bob, Claire, and that's what it was at the beginning. Then we removed it and we printed out the list again, and you can see that Alice has disappeared. So that's fantastic. We've managed to remove Alice from the system as we wanted. So now sometimes instead of deleting a specific value, let me just cancel the program here. Sometimes instead of deleting a specific value, you want to delete a specific index or a certain slice of indexes from a list. So for that, you'd use the del keyword. At the minute, we've searched for the value Alice and deleted Alice. Maybe we just want to delete index 1 or index 2 without really knowing what that value is. So for that, as I said, we need the del keyword. So if we create a list called L, and I create, it's 1, 2, 3, 4, 5, whatever. Let's say I want to delete the first index. For that, I'd use del L of 0. Okay, and that's just going to remove that from there. So L is going to be here. So I can't do L.remove 1 because I didn't know hypothetically, that 1 was in the list. Okay, if I didn't know what the value was, I just wanted to get rid of the index, whatever was there, then I would use the del keyword. If I knew specifically what I wanted to delete, then I would use the remove keyword. Another reason to use del is because, do you remember when I said that the remove keyword only removes the first instance? So let's say if I had something like, let's call this list example, and I had A, B, C, A, and A, and B. Let's do that. Okay. If I do example.remove A, and I look at example again, it's only got rid of the first one, right? But A is still here. So let me recreate it. What if I wanted to get rid of this one? Well, I know that that is at index 0, 1, 2, 3. Okay. So I would use del example 3. And that now, if I show example, has gotten rid of that A right there. So it gives you a bit of flexibility on how you want to remove things. So this is definitely a useful keyword you're going to want to keep in your back pocket. Oh, and by the way, yes, you can delete slices using the del keyword. So example at the minute is ABCB. So let's see if I wanted to get rid of just the first 2 elements. What I could do is del example 0 to 2. So because 2 is here, we want to go up to there. That's going to cut from there backwards. And now if we look at example, you can see that we've only got CB left. So you can cut out slices as well. Okay, so we're nearly there. I mean, let's just go back to see what we've done. We've currently got a list of known users. The computer is going to say hello, very politely, or good old Travis, and it's going to ask the user for their name, strip off any white space, and capitalize it so that we can compare it with everything else in our database. Now, if the name is in our list of known users, we're going to print hello, hello that name. So if their name was Bob, hello Bob, and then ask them if they'd like to be removed from the system. And if they enter yes, say they enter it in whatever case, it's going to be turned to lowercase, and that's going to be saved in remove. If remove is lowercase y, meaning that they entered yes, then we're going to basically remove we're going to remove that name from our list of known users. And I'm just going to get rid of this this printing because that was just for demonstration purposes. So we're nearly there. All we've got to do now is we have to see if their name isn't in the list of known users, right? So if they are an unknown person, we want to say that we don't know them and ask if they'd like to be added to the list. So we're going to save that for the next lecture because this one's also getting a bit long. And I'll see you in the next video to finish up our work with Travis. Hello there, you beautiful people, and welcome back. Now in this video, we're going to finish off building Travis. So we're nearly there. We've just got to do something if the person isn't recognized. Well, first of all, because Travis is a very polite security system, we're going to get rid of this ugly message that says name not recognized. And we're going to put something a bit more friendly. So I'm going to make it say, I don't think I have met you yet. Then put that in there, the name. So if their name is Dan, I don't think I've met you yet, Dan. Now that's much better. So we then need to ask them whether they would like to be added to the list. So let's do that with an input statement. I'm going to create a variable called add me equals input. Would you like to be added to the system? Tell them yes and no with the options, question mark, thing like that. We're just going to, I'm actually going to go up here and add a strip and lowercase, and then down here add a strip and lowercase. So now we've basically going to get the person's input. If they enter Y, it's going to, that means they want to be added to the list. So now we need an if statement to check for that. So if add me equals Y, now we just need to add them to the list in here. Okay, so I'd like to show you how to do that. The way that we can add people to a list is use the append list method. So let me show you how we do that. We just type known users dot append that name. And it's as simple as that. The append method is going to take whatever you put inside of it. In this case, let's say it was, I don't know, John, right? If their name was John, we're going to append John to the end here. So let me show you that in example. We print the known users before we append, and we're going to print it after. Now let's save and run the code. And we're going to see, my name is Travis, what is your name? Let's say John. I don't think I've met you yet, John. Would you like to be added to the system? Let's say yes. We can see at the beginning that John isn't in the list. Then we append him, and he comes right to the end here. So that's how you can append names to, or append any item to a list in Python. So we're pretty much there, you guys. Let me just go and have a look at this code again to make a few finishing touches. So I'm going to first get rid of this whole print thing that I just used to display the point to you. Then we're going to get rid of that. Okay. Now let's say they enter no to any of these things. So let's say if remove is yes, then remove them. Else, if remove is no, then print no problem, I didn't want you to leave anyway. Okay, so that's the first one, giving him something nice to say, and then we can just down here, elif add me equals no, then known users, oh no, not known users, print no worries, see you around. And that is pretty much it, you guys. Now, the cool thing, because I've got it in, let's cancel this. The cool thing, because I've got it in this while loop, it's going to continue to run over and over and over again. So let me show you what happens. My name is Travis. What's your name? Z is my name. I don't think I've met you yet, Z. Would you like to be added to the system? Yes. Hi, my name is Travis. Now, if I enter my name again, right? Hello, Z. Would you like to be removed from the system? Let me say yes. Hi, my name is Travis. What is your name? Let's say Z again. So you can see the way the list is updating on each loop of the program, which is amazing because now we're keeping a data structure, or pretty much a database, isn't it, really, that is being continually updated and kept in the computer's memory that we can do with whatever we want. And it contains more than one piece of data. So I hope you can see just how powerful that is. So I'm just going to click no here. No worries, see you around. And that's the end of that. Hello there, you beautiful people. So now that we've got Travis fully operational and up and running, there are a few more ways to add things to lists that I want to show you. So the first is just to use the addition operator. As we can tell, this operator has a lot of different uses. So lists, only lists can be added to lists. So for example, if I create a list called A, and I set that equal to 5, 12, 72, 55, and 89. What that's going to do, that's going to be absolutely fine. But if I want to add the number 1 onto the end here, if I try to just type A equals A plus 1, we're going to get a type error. And that's because you can only concatenate lists with lists and not integers. Now, the way that we can fix this is, well, first of all, of course, we could just use the append method that I showed you before. Or what we could do is we could type A equals A plus 1, but put the 1 inside a set of square brackets. And that is basically going to say, okay, add to A this list with just the number 1 in it. And that's going to work absolutely fine right there. But what if we want to add a string? So if I try to do A equals A plus BCD, let's say, this is still going to give a type error because you can only add lists to lists and not strings. However, because strings are an iterable data type, there are 2 ways to fix this issue. So first of all, we could do A equals A plus BCD and put all of that inside a list of its own. And we're going to see that you have just one element added on to the end. But the other option, so that's the first option. The other option is to use the list method. Now this is going to do something quite different. So if I do A equals A plus list of BCD, this is going to do something quite different. we're going to see here that instead of just adding BCD as one whole element, it's added B as an element, C as an element, and D as an element. So each of the elements of the string has been added as its own element to the list. Now you can't get this functionality for integers, and the reason is integers aren't iterable data types, and therefore they can't be converted into lists. So if I try to do A equals A plus list of 1, 2, 3, that's not going to work, because as it says, integer object is not iterable. But numbers are also kind of easy to work with, in the sense that all we'd have to do is type A equals A plus 1, 2, 3, like that, and that would add them individually on the end. There is another trick though when you're working with numbers. Say for example, because I can't convert numbers into lists because they're not iterable, but I can convert numbers into strings. So if I did A equals A plus the string 1, 2, 3, right? That won't work because I'm still just trying to add a string. But if I convert that string into a list, so I convert the number into a string, then convert the string into a list, we now see that we get 3 strings with each of the numbers added onto the end there. So that's another potential option you might want to explore. So I thought I'd throw that in there. So let's just reset A really quick to avoid any confusion as we go forward. So A is this, and we just press enter to copy it to the next line. A equals. So what if I wanted to add a list of numbers, right? So instead of just doing A equals A plus 5, 6, 7, 8, let's say, that's just going to add them all individually. So what if I wanted to add this list as its own element? So the way that I'd do that is I'd go A equals A plus that 5, 6, 7, 8, just like we did before, but we're going to put another square bracket around it. And that is going to put a square bracket basically around that list and add it as its own element. So now it should be the final element of the list. So if I do A minus 1 to get the final element, we see that we get that list out. So that's a way that you can do that. That's how you can add in extra lists as their own elements. Alternatively, you could just use the append method to do that. So a.append the list. Let's try another one. 10, 11, 12, and 13. That's just going to add that as its own list again, you see, because I put a list inside of there. So there's loads of different ways to do these kind of things. But there is a very important issue that I want to flag up when you use the append method that can cause big problems if you don't know about it. And this issue is that the append method returns an empty value. So let me show you what I mean. If I have A, I'm just going to reset it again, just up here. So A shows up completely normal. If I do A equals A dot append 10, now if I try to look at A doesn't show up. And the reason is A dot append 10 gave back some empty space. That empty space, because of the assignment operator, was then saved in A, which basically just deleted the data, right? So if I find the type of A now, it's going to tell me none, which is another data type, but it's basically blank space. If I show you the type of A.append 10, what is the type that A.append 10 gives back? Well, actually, it's not going to work because I can't append anything to an empty list. So let me just make a blank list like this. Now, if I do try and find the type, it's going to tell me none, right? Because the type of whatever the append method gives back is none, and we saved that none into A, which basically deleted the whole thing. So that's something to really be aware of. Now, at the minute, I'm just showing you how you can add things to the end of lists. But what if we kind of wanted to insert something at any point in the list? Let's just make A long again. Let's make it what it was before. Okay, so now we've got our original, we've now got our original A back. Let's say we wanted to insert 100 between the number 12 and the number 72. So for that to happen, we want the number 100 to kind of be inserted here, right, and move everything along. Well, here is index 2. So what we can do is a dot insert, right? Use the insert method. We want to insert at index 2 the number 100. And if I show you that now, we can see that the insert A is inserted 100 at index 2. And you can also insert slices. So if I do a dot insert at index 2, let's say we wanted to insert 10, 20, 30, like that. We've kind of put in together, we've inserted the whole list at index 2. So that's something to bear in mind right there as well. So insert is something else that's very useful. But notice as well, I'm not typing a equals a dot insert, let's say 250 or 60. Because if I do that, now a has been deleted again, because this method, again, has returned none, and that's been saved in a, unlike string methods where you do need to do this. And the reason is lists are mutable data types, not immutable, they are mutable, which means they can be changed after you've defined them. If I had a string and I had it as 1, 2, 3, I can't change this. So let's try and turn the letter 1 into 5. It's going to give me an error. String object does not support item assignment. But if I had a list called A and I had that as 1, 2, 3, and I tried to change the first letter of A to be 5, that's possible, okay, because lists are mutable, strings are immutable. So in this insert method and the append method and methods like that, list methods, it's kind of changing the list behind the scenes, and that means you don't need to reassign a to the new value. So you don't need to type a equals a dot append 5, because if I do that, a has been, it's been turned into a non-type. Same goes for the insert method. So just be aware of those things right there. So over the last few lectures, you've now built a security system. You've learned how to combine data structures and logic by using the in keyword. And you also now know how to create lists, how to add things to lists, how to remove things from lists, which, by the way, the remove method as well, if I did a equals a, let's just make a thing called a123. If I did a dot remove 3, that's going to work fine. But if I tried to do a equals a dot remove 2, again, that's also done the none. So bear in mind that all these list methods pretty much work the same. So you now know how to add and remove things from lists, how to create them, how to use them with logic, and you also know a few things to watch out for. So well done. I mean, we're pretty much there with understanding how lists work. So up next, we have Python's second type of data structure, which is called the tuple. And tuples are very simple. They basically work exactly like lists. So we're pretty almost like lists. There's a slight difference. So we're not going to spend too much time on them. But that doesn't mean they aren't important. They all have their own place. So I'll see you in the next video for some tupley goodness. Hello there, you beautiful people, and in this lecture you're going to learn about another one of Python's data types, tuples in this case. Now, tuples are quite common in Python, but they're very similar to lists in how we use them, with just a few differences, so this lecture won't be long at all. By the end of this lecture, you're going to know what tuples are and how to make them. You're also going to learn what makes them different to lists and when you should use tuples for maximum effect. As an added bonus, I'm going to show you a cool trick that you can use to create multiple variables in one line of code. So let's go. Okay, so what is a tuple? Well, a tuple is simply a data type in Python that works very similar to a list. The only difference is that once you have created a tuple, it cannot be changed. So because a tuple cannot be changed once it's been created, tuples are called an immutable data type. So let's go ahead and actually create a tuple. They're rather simple to make. Let's say we have a variable called our tuple. We can create that by just having a bunch of values that we separate with commas. So let's say we have 1, 2, 3, A, B, and C. Now if I just do that and click enter, That is created our tuple. So I can check this by using the type function. If I do type of our tuple, you can see that it says it's of class or data type tuple. So that's easy enough. Now, while we can define tuples using only the comma, it's much more common, for the sake of clarity and being obvious about what we're doing, to actually surround tuples in parentheses, like this. So I'm just going to copy and paste that line and just put some parentheses around it. This is how we normally see tuples created in practice. This gives exactly the same result. As you can see, there's no errors. The type of it is still a tuple, but it's much more clear about it's much more clear what you're doing. So I'm going to stick to using this method in the future. Tuples are an iterable data type, just like lists and strings, and this means tuples are made up of little pieces called elements, and we can select each of the elements and slices of elements from tuples just like in lists and strings, using the element index. So for example, if I had our tuple, and I took the elements 0 to 3, using square brackets just like normal, it would give me a mini tuple of 1, 2, 3. So when you slice a list, you get a mini list, and when you slice a string, you get a mini string, and when you slice a tuple, you get a mini tuple. Simple. So the only real difference between tuples and lists is that you cannot change tuples after you've created them. Lists are mutable and therefore can be changed. Tuples, like strings, are immutable and cannot be changed after they've been defined. So if I make a list called our list, and I set that equal to 1, 2, 3, 4, 5, 6, 7. Now I can actually change index 2 of the list, like this, our list, index 2, and set that equal to 100. Now if I show you our list, we're going to see that 100 has replaced 3, because 3 was in index 2. So that works fine for lists. But if I try to do that with our tuple, let me show you what that is again. Our tuple is this. If I try to replace the 3, again, our tuple of index 2 equals 100, and I press enter, we're going to get a type error, and it's going to say the tuple object does not support item assignment. And you get a similar error for strings. So if I had 1, 2, 3, 4, 5, 6, 7 as a string, and I tried to, let me save that as S. So let me just do that real quick. S equals 1, 2, 3, 4, 5, 6, 7. If I try to change the second element of that to another thing, I don't know, let's say A, it's going to say again, string object does not support item assignment. So you've got the same thing going on, because tuples are immutable, strings are immutable, but lists are mutable and therefore can be changed. Now this behavior of tuples, the fact that they combine the ability to store multiple data types in them at once, store multiple pieces of data in them at once, but they cannot be changed, makes tuples excellent for a data type where you want to store pieces of data, but you don't want that data to ever be accidentally changed or altered in any way. So that's why you tend to use tuples. You've got some data that you want to protect but refer to later, so you use a tuple for that, whereas a list you might accidentally modify it without knowing. So tuples, you use them to protect pieces of data. You can also use the tuple function, or not tuple function, and you can tell we got it right because it went purple, to convert other pieces of data into a tuple. So let's say we have a list. I'm going to call it A, and this is going to be 1, 2, 3. I can turn A into a tuple by typing tuple of A, and that's going to give us that back. A hasn't been changed, but if I typed A equals tuple of A, now A is a tuple. So, and this will work for strings and other stuff like that, so just bear that in mind. Now, one cool trick that you can do with tuples is you can do multiple assignment. So let me show you what I mean. If I had A, B, C, this is going to be a tuple, right? Or if I did it a bit more explicitly. Yeah, like that. So A, B, C equals 1, 2, 3. Now, what happens if I look at A? A is 1, B is 2, and C is 3. So you can see the way that we actually define multiple variables in one go. Now, you can actually do that, which is good. That's quite cool on its own, but you can actually do that with other iterable data types as well, like lists and strings. So, for example, if I used a list, I could have D, E, F equals 1, 2, 3, and we're going to see that D is is 1, E is 2, and F is 3. I could also have G, H, I, and set that equal to, let's say, 7, 8, 9, right? Now, G is going to be 7, H is going to be 8, and I is going to be 9. So if you've got an iterable data type, whether it be like a tuple or a list or a string, but you've got some kind of, I suppose, a tuple on the left, you can assign them to individual items like that. So that's a cool trick. So, you know, every now and then, you might want to keep it in your back pocket for a cool party trick or something like that. Awesome. So that's really all there is to tuples. Tuples basically work like a list, except you can't change them once they've been made. This makes them very useful for keeping data from accidentally being messed up in your program. You can create tuples by using the tuple function, or simply by separating a few values with commas. For more clarity, you should make sure that you surround your tuple definition with parentheses. As a bonus, you've learned how to use tuples, lists, and strings for multiple assignment. This trick won't be used everywhere, but it's a nice bit of style to throw around here and there in your code where appropriate and save a bit of space. So check you out. You've now actually added another data type down to your repertoire. Nice and easy, right? So up next, we have another complete game changer of a data type, Python's dictionary. Dictionaries allow you to store data under easy to remember keys, all within one data type. We'll be using this data type to make a cinema booking system later in the section, so I don't want to spoil too much here, so I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on dictionaries. Now, dictionaries are a super badass data type in Python and are possibly my favorite of all the Python data structures. So in this lecture, you're going to learn what dictionaries are, how to create them, and also we're going to go through a quick example of how to use them so you can get a very good idea of how dictionaries work. Let's do it. Okay, so first of all, what the heck is a dictionary? Well, if you've ever used a real-life dictionary, you know that you have a bunch of words and each word has a definition for it in the dictionary. People look up the word and they get the dictionary definition back. Python dictionaries work in the same way, except they're much more powerful. First you look up a key in the dictionary, then you get back some value. So let's see this in practice. Here I'm going to make an empty dictionary called students. So I'm going to type students equals this empty dictionary. So as you can see, these squiggly brackets are used to create dictionaries. They're the same symbols that you use in string formatting, but they're not linked at all. It's just the same symbol. So inside of here, we want to define some keys and assign them some values. So for this, I'm going to define the keys as student names, and the values are going to be the students' ages. So let me just write this again. I'm going to have Alice as a key, and I'm going to type in age 25. I'm going to have Bob as another key, and we're going to have him as age 27. And you can see the way that I'm doing it. This is a key, and then I have a colon, then the value, and then a comma to separate the next key and value, and a comma to separate the next key and value, and so on. So we've got Claire. She's going to be 17. We've got Dan, who is going to be 21, and we're going to have Emma, who's going to be 22. Okay, so let me just click enter on that, and that's gone in fine. So here's our dictionary of students. Pretty easy, right? Now notice how each of the keys is a string. I can't just put text in there without the string quote marks, because otherwise Python would give me a name error. So for example, if I tried to write, error students, right? This is not going to work. Say if I just tried to type Alice 25, Bob 27, let's see how that goes. That's going to give me an error because it's going to say name Alice is not defined. It's looking for a variable called Alice. But if I put quotes around it like this and make it a string, then that will work. Okay, now it's going to tell me Bob isn't defined, right? So you get the point there. So we now have a dictionary up here set up with a bunch of items. Each item represents a student, and each item has a key and a value. So we have items, keys, and values. Now, how do we look up a key? Right, so that's very easy. All we have to do is type the name of the dictionary. So we type students. Then we type some square brackets, like we did with slices, and inside we type the key. So for example, if we want Dan's age, we would type in the key of Dan, and when we press enter, it's going to look through all the items, find the one that has the key of Dan, and give us back the value, which is 21. Sweet. So what if another student joins the class who's called Fred, and Fred is 25? Well, what we can do is we can just assign the key of Fred to the value of 25 in the student's dictionary, like this. We type students, we'd put the key of Fred, and we'd set that equal to 25. Okay, now when we look up Fred, like this, students look up the key of Fred, it's going to give us back 25. So what if Alice, our first student, had a birthday and became 1 year older to become 26? Well, all we have to do is type students, Alice, right? At the minute, she's 25. Students, Alice equals 26. And that is going to now, if we look up Alice again, she's now got 1 year older and she's become 26. But Fred is not a particularly dedicated student and very quickly drops out of the class. So how can we delete Fred from our dictionary of students? Well, do you remember the del keyword from before when we were working with lists? Well, all we have to do is type del students Fred. And this is going to delete the item with the key of Fred along with any associated values. So Fred should be gone now. So when we look up Fred, we are going to get what's called a key error, saying that basically the key Fred could not be found. We can get a list of keys from the dictionary using the dictionary keys method. So if I had students.keys, right? This is going to give us all the keys, but in a rather weird dict keys data type, right? So the dict keys data type is iterable, but it isn't indexable. So we can't really just pick out one of them. Like, for example, I couldn't go students.keys and I pick out like the first index or the 0th index. That won't work, right? Oh, sorry, I spelled students wrong. Let's give it a fair chance. That won't work, right? It says dict keys object does not support indexing. So, but the way that we can access certain indexes is to turn student keys into a list. So if we do student.keys and we turn that into a list, right? I'm going to save that as something called A for now. That's going to work. And now we've got a list. So now I can just take out the keys at any point, right? Like that. We can also take out the values by using the .values method. So students.values is going to give out a dict values, which has the same issues that we had before. These are actually very compatible with loops, especially for loops, just like the dict keys was, but we haven't covered those yet. So the way that you can actually convert this into a list, if you want to pull stuff out, is you just go list students.values. Like that. That's going to convert into a list, and then you can pull out slices, for example, as much as you'd like from there. But if I just tried it with students.values and tried to take a slice of that, that will give me an error because it says dict values object is not subscriptable or it's not indexable if I try to pick just one of them. So you've got these limitations, but you can always convert them into a list. But an important thing to note here is that a dictionary, unlike a list or tuple, does not have an order. The only way to access an item is to use its key. You don't use an index. So if I print out students, right? So let me print out students. You can see the way that it's been printed here. Dan, Alice, Bob, Emma, Claire is different to the order at the top that I defined it in, which was A, B, C, D, E, right? Because dictionaries don't intrinsically have an order. They basically just store the keys and values together. The keys and the values are always matched together, but the order in which they appear doesn't necessarily matter because you only use the key that you want to access the value. You don't use, like, for example, an index. I can't use student 0. It's going to say there's no key 0. You have to use a key. Okay, so this is probably a good place to take a break and digest what we've learned. First, you've learned that a Python dictionary works just like a real-life dictionary, in that you first look up a key, just like you'd look up a word, and then you get back some information associated with that key, or a value. So each key-value pair is called an item. You then learned how to create a dictionary, and we made a dictionary of students. Each of the keys in our dictionary was a student's name, and the value was the student's age. You learned how to look up a key in the dictionary, using the square bracket syntax, and then we had the delight of a new student called Fred joining our class. You learned how to add the student to the dictionary simply by assigning a value to a new key, but unfortunately that student decided to go on and do other things and dropped out, which was quite convenient for you, however, as you got to learn how to delete an item from a dictionary using the del keyword. You can also update values, like Alice had a new birthday and her age changed from 25 to 26. All you have to do to change a value or in a dictionary is to take the key and assign it a new value. So for example, students of Alice, you just assign it whatever value. So let's say in 1,000 years, Alice will be, she'll be 1,026, I suppose. Damn, she old. So then we learned how you're going to get out all the keys from a dictionary and all the values using the dot keys and the dot items function. But you can also, the dot values function you saw. But you can also use the dot items function to pull out all the items. So if I did students dot items, you can see it gives us basically a list of tuples, and each tuple is an item. So that's quite a lot of awesome stuff about dictionaries that we've learned here today. It's quite a lot the dictionaries allow us to do, but we're going to take it to a whole new level of awesome in the next video, where you're going to learn how to give a single key multiple values. So for that, I'll see you in the next video. Hello there, you beautiful people, and in this lecture you're going to see just how powerful the dictionary data structure really is by allowing each key to hold multiple values. So this effectively makes one dictionary capable of storing a virtually unlimited amount of information, and each piece can be neatly ordered and uniquely accessible. So in this lecture, you're going to learn how you can combine dictionaries with lists and with other dictionaries so we can store more information about our students, such as their student ID and their grade, for example. So by the end of this lecture, you're going to be the Python data structure boss, and you're also going to know how to combine together different data structures into your bigger data structure, effectively however you like. So let's get into it. Okay, so let's recap what we have from last lecture. We had a dictionary of students like this, and we created it so that we had several students in it. We had Alice, and her age was 26. Well, not 16. 26. We had Bob, who was 27. We had Claire, who was 17. We had Dan, who was 21. And we had Emma, who was 22. Okay, so we had this list of students, and each student, their name was a key and their age was a value. And you can see that we only have one value for each key. Now, what if we wanted to store not only the student's age, but we also wanted to store their student number as well as their grade? Well, what we can do is, instead of storing just an integer in each of the values, you see how we've just got an integer, an integer, an integer, an integer. Instead of storing just an integer, we can store a list. So let's say the first thing we put is their student number, then their age, and then their grade. So I'm going to show you how we do this in a script. Let me just make a script here. And I'm going to save this on the desktop, again, in the Python Bible. And I'm going to call this students.py. Okay, so let me just take this, save me typing if I can. We'll give it a go. Hopefully I can copy and paste. And move into here. Yeah, there we go. So, right. So what I'm going to do is I'm going to make in here our dictionary. And I'm just going to break this up a bit. I'm going to put like an end line after each one of these. Which you can do in Python, by the way. This is actually totally allowed. Okay, so, and I'm just going to put that down like that. Okay, so instead of just having their age, I'm going to have a list here. And the first thing is going to be their student number. So let's say that's ID 0001. Her age is 26. And she is getting an A. Okay, then we're going to have another list for Bob. Bob's ID is 0002. He's going to be 27, and he's getting a B. Claire is going to have her own ID. She's going to be ID 0003. She's 17, and Claire is getting a C. Dan, ID 0004, going to be he's 21, and he's going to be getting that. And then Emma, ID 0005, 22, and E. Okay, so that works, right? So if I run this, just to show you, hopefully we don't get any errors, you see that's worked totally fine. So now what if we wanted to get all of Claire's data? Well, to do that, we have to print it because we're in a script, but we just type students of Claire, and that would give us all of her data, but we need to print it. So let's just print that, and we're going to see that indeed her ID, her age, and her grade come up. So what if we just wanted to get her ID? Well, what we could do is we could go in here, and instead of just printing all of her data, because her ID is the 0th index, it's the first thing in that list, we just put another square brackets and put the index 0. Then when we run that, we just get her ID. So what if we wanted to get Dan's age and Dan's grade? Well, what we could do is we could print students of Dan. Now his age and his grade. Well, his age is index 1 and his grade is, well, basically we just need the rest of the list from here, right? So we can just say from index 1 all the way till the end. And when I save that and run, now we get his age and his grade. So you can see the way that we can apply slices in our dictionary to get the information that we want. And this is all great because we've saved a lot of data about each student in one place. And as long as we know the order that each piece of information is stored, we know that the ID comes first, then the age, then the grade, then that's absolutely fine. But what if we wanted to make it a bit more clear what each index was? What if we didn't just have to remember that ID came first, and then the age came second, and then the grade came third? Well, that's what I'm going to show you how to do next. So what we can do is we can give each key its own dictionary as a value. So let me show you. I'm going to go back into the script. And in here, instead of having a list as a value, I'm going to make a dictionary. So what I'm going to do is I'm going to delete this, and I'm going to type in here another dictionary, and I'm going to say ID is ID 0001. Then I'm going to have a comma. Age is 26, and the grade is A. And I'm just going to copy and paste this and fill in the appropriate values for each student. So Bob, his ID is ID 002, he is 27, and Bob has a B for a grade. Then Claire, ID 0003, her age is 17, and she is on a C. Then we have Dan, who's on ID 0004. Dan is 21, and he's on a D grade. And then you've got Emma, who has ID 0005. She's 22, and she is on an E grade. Okay, now this looks quite badass, right? We've got a dictionary with dictionaries and keys and all sorts of stuff inside it, but it's actually really easy to use. So now I'm going to get rid of this, and what if we wanted Dan's age? Well, all we've got to type is students, Dan, and his age. Okay, now I need to print this to show it to the screen, but now we're going to see Dan's age, which is 21. And if we look back in, we're going to see, oops, wrong script again. There we are. Dan's age is indeed 21. So what if we wanted Emma's ID and Emma's grade? Well, we can make a new list that contains those. So if I said print, let's say I wanted to print students, Emma, her ID, and students, Emma, her grade. And now I save and run it. We're going to get her ID and her grade. And there we have it. I mean, how freaking awesome is that, right? As you can see, Python's dictionaries are an incredibly powerful data type and are really simple to use when you set them up properly. In this lecture, you learned how to assign lists to be values for specific dictionary keys. And while this was great because we could take slices of the output and so on, it was kind of awkward to use if we didn't know what order the list was in. So to fix this, you then learned how to assign dictionaries to be values for Python dictionary keys, which brought us to a whole new realm of dictionary epicness. So you can now use keys with easily recognizable names to refer to each of the values in a Python dictionary, and doing that was super easy. And that brings us to the end of our discussion of Python dictionaries. In the next lecture, we're going to actually apply this stuff to create a cinema booking system that lets the user book tickets to see a film. If the user's old enough and there are enough tickets left, we're going to let them book to see the film. And if they're not, then we won't. Awesome, right? We're basically creating a development business right now. So I won't spoil all of the goodness here, but that project is really going to tie together everything we've learnt in the course so far, all the way from variables, through logic, and through data structures, and all the other goodness. So I'll see you in the next video. Hello there, you beautiful people. Now it's time to put our data structure skills to the test by making a cinema simulator. So this project is going to let users choose from a range of films, and the user will pick a film, and then the program will ask them for their age. If they're old enough to watch the film and there are enough seats available, then the program will let the user book to see the film. If not, the program will tell them that they're too young or there's not enough seats available or whatever. So pretty cool, right? Now, by the end of this project, you should have a great understanding of how variables, logic, and data structures all tie in together to build programs. So I can't wait to get started. Let's jump right in. So first of all, as I'm sure you know, first thing we're going to do is create a new script. I'm going to save that on the desktop, Python Bible, cinema.py, save that, maximize it, and we're all good to go. Right, so up first, we're going to create some kind of data structure to store information about our films. Now I'm going to use a dictionary for this, as each film is going to be its own key and have its own data. So since this current video is being filmed in about the middle of 2016, I'm just going to make you a list of some of the current films with random ages and seat numbers, but feel free to create your own dictionary with any films that you want. So the dictionary is going to store the age rating for the film and also the number of seats left. So let's make a dictionary called films, and I'm just going to create it like that. Okay, now inside here I'm going to put Finding Dory. 3. So the age for this I'm just going to say is 3, and there are 5 tickets, let's say. So, and then you're going to have Born. Pretty sure he's in the cinema. 18 and 5. Tarzan. Ghostbusters. Okay, so let's put that in there, 12 and 5. Okay, so there we go. We've got add dictionary of films. Obviously, you can add as many as you want and mix and match for what you desire, but I'm just going to leave it with those few. So I'm going to do a little cheat again now, and I'm going to use a while loop, so this program is going to run over and over again, just like we did for Travis. But don't worry, we're going to cover loops in detail in the next section, so just bear with me for now. I'm just going to type while true, and now put our code inside here. Okay, so now we need to ask the user what film they want to watch. So as a micro challenge, go ahead and ask the user what film they want to watch using the input function, and store that choice in a variable called choice. You know the drill. Pause the video, have a go, and come back to see how you did. Okay, so how did you get on? I'd have done it like this. I'd have just gone in here, typed choice equals input. What film would you like to watch? Like that, and just in case they enter some white space, I'm just going to strip it off right there. And also, actually, because, as you can see, every single one of the films that I've put here in a key, every word starts with a capital letter, right? So what I'm going to do is I'm going to use the title string method as well to convert whatever they put into title case, so that if they enter Ghostbusters, then Ghost will start with a capital G and Busters will start with capital B, regardless of how, they might type it themselves. So we're just going to do that right there. Now, if you followed along with this, and if you got that actually, or you've just been following along, then you're doing absolutely brilliantly, because now we're going to start kicking off to more hardcore things. Okay, so now we need to check if the film that the user has chosen in choice is in the list of films. Now this is very easy to do just by using the in keyword, right? So let's just check if choice in films. Now, actually, I'm just going to introduce you to the pass keyword. The pass keyword basically just tells Python, just move on. Okay, this is just a blank placeholder. We're not going to actually write the code in here yet. I'm just building the structure. So if the choice is in there, just pass and do nothing. Otherwise, print, we don't have that film. And I'm going to make it build suspense, right? So that should be pretty good like that. Now when we run it, okay, when we run it, I'm going to say Tarzan. It's not going to do anything, right? Because it found the film, but it just saw pass and went back around the loop. Now, if we run it again and say Rocky 7, let's say, then we don't have that film. So our logic is working, which is brilliant. Okay, so let's stop this thing running. The next thing we've got to do is we've got to check whether the user is old enough to watch the film. So what I can do is if the choice is in the films, right? If the choice is there, we need to check whether the user's old enough. So let's say age equals input, how old are you? Okay, and I'm going to strip whatever comes off from there. So how can we take whatever they put and compare it with the age that's in here? Well, first of all, we actually need to make sure that age is a number. Now, if you remember, when I was talking about the input function, it always brings in a string. Okay, even if you type a number, it saves it as a string. So to convert all of this into an integer, we need to actually cast it from a string into an integer. So here we get a string, we strip any white space off it, and then we convert that whole thing into an integer, into a number, and save that in the age. Now what we need to check is if that age is greater than or equal to the age requirement for the film. So how do we know that? Well, we go in the films dictionary, look up the film that they chose. So let's say they entered Tarzan, right? If we look up the key of Tarzan, it's going to give us back this list. Now, the age is the first element in that list, so I'm going to type in index 0. So we're looking up the choice as a key in the films. Now it makes sense why we had to get it in title case and we had to strip everything off. And once we've got the value, which will be this list, we're going to look up the first element in it, which corresponds to the age. And if their age is greater than or equal to that, then we're going to print enjoy the film. Okay? We'll come on to tickets in a little bit. But otherwise, if they're not old enough, we're going to print you are too young to see that film. Okay? So let's have a look. Let's have a look at how that works. So what film would you like to watch? Let's say we want to watch Tarzan. How old are you? Let's say I'm 5 years old. You're too young to see that film. Okay, so let's say if we want to watch Tarzan. Again, let's say now I'm 99. Enjoy the film, right? So that works absolutely fine right there. Let's take another example. Let's say if we want to watch Finding Dory. How old are you? I am, say, 9 years old. Enjoy the film. That works fine as well. So let's cancel that out. And you're pressing Control C. And now we need to build the bit where it checks the number of tickets. So to check whether there are enough tickets, instead of just letting them, enjoy the film straight away after checking their age, I'm just going to write here, check user age in here. Wait a minute, just with a comment. Check user age. Now in here, we're going to check enough seats, right? So how do we know the number of seats? Well, the number of seats is this. It's the second element. So if the films of that choice, so this is the basically this list for the corresponding film. If the seats of that, which is element 1, is greater than or equal, but we can just say if that's greater than 0, right? Then we're going to tell them enjoy the film. We tell them enjoy the film, and we're going to subtract 1 from the number of tickets left. So films choice 1. Oh, I'm messing up. Films of choice 1 equals films of choice 1 minus 1. Okay, so we're taking whatever the value is for the number of tickets, and we're subtracting 1 from it, then saving it back in there. Another way that we could do this to make it a bit clearer, we could say num seats equals films of choice 1. Okay, and if num seats is greater than 0, we're going to say enjoy the film, and num seats is going to become num seats minus 1. But actually that bit won't work. Actually, no, we do need to change that. Films choice is going to become we did need to keep that the way that it was before. So we're just overwriting the number of seats right there. And that's pretty much it, to be honest, I think, you guys. Let's watch that work. So there's always 5 seats, right? So what film would you like to watch? I'm just going to say Tarzan because it's easiest to spell. How old are you? Let's say 3. You're too young to see that film. Okay. If I'm Tarzan, again, watching it. How old are you? I am 15. Okay. So now there should be 4 tickets. Tarzan, I'm 15. Okay, now there should be 3 tickets. Tarzan, I'm 15. Now there should be 2 tickets. Tarzan, 15. 1 ticket. Tarzan, 15. Now there should be no tickets left. Tarzan, 15. And it actually didn't say enjoy the film. Okay, did you notice the way that we ran out of tickets and it didn't say enjoy the film? We need to put in just another message in here. If number of seats is greater than 0, then do all that. Else, print, sorry, we are sold out. Now, you can trust me that works, or you can run the code yourself. But trust me, that's gonna work fine. One thing that I do want to highlight, though, can you see the way that we've got if statements inside of if statements inside of if statements and all sorts of stuff going on there? The way that Python works to have something inside something else is you can see that it's indenting it. I mentioned this a bit earlier in the course, but it makes more sense here. There's a certain amount of indenting going on, and this saves you from having to type loads of brackets and loads of stuff like that, which makes your code quite ugly, like in programs like Java and C and things like that. But you do have to have the indentation, otherwise Python just won't work. It won't be able to tell what's inside of something else. So make sure you get your indentation right. Idle's going to do it for you pretty much. I mean, if you just go to the end of the line and press enter, you can see the way that it's automatically indented. And if I typed another if, it's going to automatically indent it again. So, idle's going to help you out with these things, but that does need to be right. So if your code's not working and it says indentation error or something like that, that's the problem. But awesome. Well, I mean, you see how quick that was? We've just built a program that can actually check whether a user is old enough to watch a film and whether there are enough seats left. Now, the system also updates itself when someone books a film and also reduces the number of seats by 1 when someone purchases a ticket. Now, if you understood all of that and followed along and did it yourself, you should be so proud of yourself, honestly. You're learning so much, and you should share this victory with your friends so they can celebrate along with you. This is a really big achievement. I mean, look at it, man. Look at it. You've got dictionaries, strings, lists, while loops, if statements, user input, updating variables, conditions, logic, all that stuff in there. You should be so proud of yourself. Honestly, I'm really proud of you as well. Now, in this project, we've applied data structures to create an assortment of films, use plenty of logic, data type conversions, converting here, we've been casting, and basically using everything since the start of the course into a functional program. And with that now, we're going to end on a high and come to the end of this section of the course on data structures. As you've likely learned so much from this section of the course, let's just have a quick recap in the next video to go over what we've learned, just to make sure it all sticks. And I'll see you in the next video. Hello there, you beautiful people, and welcome to the review lecture for this section on Python data structures. Now, in this whole section of the course, we've really covered a lot, and hopefully you've gotten a very powerful tool that you can use in your programs to structure your data and manipulate it really however you want. We started off by looking at lists, the most common type of data structure in Python. First, you learned the basics and saw what a list is and how to create one. After that, you learn that lists can hold different types of data, and that lists are an iterable data type, which means they can be broken up into little pieces called elements. Each element is accessible via an index, and you learn how to use indexes to access certain elements, and also how to take slices through your lists to access multiple elements at once. Then we stepped it up a gear, and you learned how to use lists to create multi-dimensional data structures like tables, and use indexes like coordinates to access certain rows and columns. You won't need this all the time, but it might come in useful when you want to make a Rubik's Cube solver or something like that. So after that, you built Travis, the ridiculous but totally lovable security robot. In that project, you learned all about how to add items to a list and how to delete them from a list. You learned how data structures can be combined with logic systems, and you also introduced to the in keyword, which checks whether some value is in an iterable data type. You also learned about the non-data type, which you learned how to manage the use of lists methods correctly so that you don't accidentally delete your data. And after that, we started talking all about tuples. You learned that tuples are basically like lists, except that they're immutable, which means they cannot be changed once you have created them, and this keeps your data safe at the expense of some flexibility. You learned how to create tuples, and you also learned a cool trick called multiple assignment, where you can create multiple variables with just one line of code. After that, we moved on to the dictionary data type. Now, dictionaries are a glorious data type that allow us to look up values with easy-to-remember keys. You made a mini database of students and stored their ages under their names. You learned how to add new keys to dictionaries, how to update their values, and how to delete them. You also learned about the keys, values, and items methods for dictionaries to get a dictionary's keys, values, and items respectively, and also how to get this information in list format using the list function. Now, as if all of that wasn't enough, you also learned how to put lists and even dictionaries inside of dictionaries, which gave your dictionaries superpowers, basically. We use this to store not only a student's name, but also their age, their student ID, and their grade. Then finally, we combined all of the stuff we've learned so far in the course to make a cinema booking system. This program combined everything we know so far about variables, numbers, strings, logic, and data structures to really show off your skills as a Python pro. So bravo! This section has really brought a lot of new skills to the table, and I hope you really let these concepts sink in, as they'll come in useful time and time and time and time and time again. Oh, sorry, was I repeating myself? Well, that's probably because the next section of the course is on loops. Loops help to automate the task of programming itself and are a critical piece of every programmer's toolkit. Loops allow you to do in one line of code what might take hundreds or thousands or even millions of lines of code to do otherwise, and Python makes them crazily easy to do. Now, you're not going to want to miss this, so I'll see you in the next video.